Well, hello YouTube, and welcome back to another episode of This Old Blainer. Yes, I know, it's been a while, and since I've done any work on this thing. It's been, well, about a year. I got into a nice little case of pneumonia last year when I started in on it during my summer vacation, and now I'm picking up where I left off last year. So today we're going to be starting to upgrade the gear train a little bit. Well, not upgrade, but repair a gear that was damaged when I was taking the whole thing apart and trying to clean it. Unfortunately, Mr. Bozo got the better of me, and in the process wound up busting a tooth off one of the gears. So I bought a set of cutters and picked out the right one. And so now we're going to be making a gear blank out of cast iron. The whole gears train, the gears are all cast iron, so I'm going to be using the same materials. And today, also in this episode, we're going to be talking about reamers. This guy's still wrapped in the original oil paper here. These are the European style reamers. They have the Morse taper on the end here, where you can insert them into the tailstock on the lathe, and then of course the nominal size that the reamer comes in. Now, the one thing that is interesting about the European, or at least the DIN norm, is that there are different sizes available as far as and that's indicated through a lettering and numbering system. This one, for example, is an H7, which means it's a nice slip fit onto a shaft on the nominal size. So this is a 30 millimeter reamer, and it goes onto a 30 millimeter shaft and is a nice slip fit so that the gear or the part will spin on the shaft. Then you also have such as say H8, which is more like a bearing kind of a, we'll be going into that when I get on the Tormek. The Tormek's going to get some bronze bushings. Bronze is on its way. But anyway, that's going to use an H8 fitting to where it's not quite as loose. There's going to be a little drip oiler going on to it, and so it will use oil as a lubricant, but it will have a tighter fit. So anyway, let me swing the camera around here. We're going to bore this slug right now. I got a cast iron slug in the lathe. Drilled it already, or small. I pre-drilled it, small hole. Now we're getting ready to drill the bigger hole, and then bore it out to a, say, 29.5 millimeters or 29 millimeters, just depending on how lucky I'm feeling that particular moment, and then we'll be reaming it to a 30 millimeters, and then we're going to make an arbor for this gear blank so that we can mount it up into the dividing head and cut the teeth. And that's going to be, those are pretty deep teeth, so it'll probably take like 4, maybe even 5 passes to cut those teeth. So it's going to be quite tedious. But anyway, let's get started on the boring here. Okay, this is a 26 millimeter drill. We've pre-drilled at 11 millimeters, and we were spinning this at 180 RPM with the 11 millimeter. We're going to try the same rip'ems with this 26 millimeter drill and see how it works. Good, nice curly chips here, so it's taking the drill bit quite well. Oops. I know there's something in this damn quill. going. Good idea to do something is to take a measurement each time you begin a new step, even though you know or think you know what size your hole is. And this one's just slightly undersized. With the old guessometer here, we're a smidge over. We're 26.005, so we're 5/100ths of a millimeter over on our nominal size. And so now it's time to bore this guy out. I already threw on the boring bore here, so now as I go in, I'm going to ease the bit into the work here, and then bring it back out. And on the dial on the cross slide, you won't be able to see that here from where you're sitting right now, but I'll bring it out 2 millimeters on the diameter, which is 1 millimeter deep cut. And I'm still turning at 180. We'll see if that works out. It did on the facing off of this with the other workpiece that I had, or the other tool that I had on here. So let's see if this will work too. Okay, got contact. So now I'm going to take it out. 1, 2. Speed up the feed a little bit. And we're getting a nice little curly chip here. Let me bring the camera around and I'll show you. There you can see a nice curly chip. Sorry about the wobble. I'm handheld right now. You can't really see it, but my boring bar, it won't reach all the way through, so what I'm going to have to do is end up taking the piece out of the chuck once I've gotten through. I should be up to 28 millimeters right now on the hole. I'll run it out here and check it here in a second and see where we're at, but I'm going to have to take it out, swap it end for end, and then do the same thing over, pour it out, and then we can ream it through. Still getting a nice curly chip. At 180 RPM seems to be about the right speed for this bit, and also for this bar, for the bar and this material that we're working here. Now we're coming up. Can't really see it on the camera. Sorry about the view. I'll move the camera around to, for the next time. Okay, we're almost to the take a measurement here, see where we're at. And we are at a smidge under 28 millimeters. So now I can take one more cut of about 1.5 millimeters, and then we'll be just about where we want to be. Now, one of the things I did to try and retain a little bit of accuracy, since I had to remove this workpiece from the chuck here, is I put a line with pencil on here, right here on the work, that lines up with number 2 jaw, and here's my key up here, and so whenever I take the thing out and have to put it back in, I just kind of line up the marks there a little bit and stick it back in. So now we're going to take this loose and bore the other end, but that was just one of the things that I was wanting to show you guys, how to retain a little bit of accuracy when things like this come up. So now we're ready to bore in from the other side, and it looks like we're almost all the way through. So just a little poke right through here, and we're ready to run the reamer into it. And that was it. So now we're going to drop down our spindle speed here just a tad. We're going to drop it down to 45 RPM. These reamers like to go a little bit slower. And I'm feeding this in with very slight pressure on the hand wheel here on the quill. As you can see, I'm just using fingertip pressure here to advance the reamer in the cut, in the hole. So here's what our chips look like. Really, really fine. That's the thing about cast. And we'll go back into the hole until we punch all the way through. And I think we don't have any more resistance on there, so we're all the way through. I'm going to run it through until we one of the things I wanted to point out with these European style reamers is you have, now this one here, as I mentioned before, there is a norm that governs these, and it's usually indicated by a letter. Let's see if we can get this in here. We should be able to see. There we go. Okay, the numbers you're seeing here, one up at the top is the date of manufacture, that's 0297, so that was February 97. Then the diameter is 20 millimeter, and then the tolerance that it's ground to is a D11, and then on the bottom is the material it's made out of. Let's see if we can get that in there. Should be able to see HSSE, and then the 20 D11, and there's the date of manufacture. Now notice also how these have a little bit of a left-hand twist to them, whereas these have straight flutes. Now this is an H7, which means it's ground to a looser tolerance. And I'm not sure if you can get an H7, you know, with these left-hand twist flutes, or if that's just something that's totally indicative of the closer tolerance. But anyway, that's one of the things I wanted to point out to you guys. Like I said, H7 on this one, rather loose fitting, and the D11, although this one, I'm not sure the D11 if it's a closer fitting or if it's looser fitting. If anybody out there knows, by all means chime in on the comment section below, and you know, spread the love, so we can all get a kind of an idea of what's going on with these things. Our gear blank mounted up on the arbor already. We're going to put a little more grunk on it here, so that way it doesn't spin on the arbor. Anyway, after reaming the hole, made the arbor. It's just standard old lathe work here. But anyway, this is a piece of 100mm string cast, and our gear blank is going to need to make, let's see, 85mm. So we're going to run it at 180 RPM like we did before, and see how this bit does. Start off with a 1mm cut. Getting a little bit of skip due to the outer round of the workpiece. I got a little idiot sheet here where I got all my dimensions wrote down, and now we can set back to work. Okay, our final diameter was actually not 85, or it's supposed to be 84. So let's check this measurement one more time. And we have 85 right on the dot. So we're going to go ahead and take it down to the final dimension. And sneak up on it here. Okay, I just made contact. So now I'm going to go exactly 1mm on the dial. And we're off. So now we're going to check our measurement just to make sure. And we're just a smidge over, so we're going to take that smidge out, that tenth, and we're getting a really fine cut now. So I'll bring you guys back when this is all done. see, we're getting a fairly decent finish on this. We're still getting a little bit of the impurities showing through here. Again, in my random lengths, are there knots in steel? Here we're seeing some of the defects or impurities or whatever it is, or downright purities of the steel, or the cast iron in this case. These aren't inclusions, they're just traits of the casting. So let's take a measurement and see where we're at. So now we've chamfered this end right over here to give it its final tooth profile. I might even bevel the back end of it here for the teeth a little more later on. It's not really necessary, but now we're going to go in for our final length here. We need 87 millimeters. We've got 99.1, and that's because this is a 100 millimeter blank. It was right at 100 millimeters, and I faced off this this end of the blank. It was a little bit of a rough cut, so I faced it off to square it up nice, so that when I put it on the arbor, it didn't try to go cattywampus on me on the arbor. So now we're going to take off 16 millimeters. Or at least make a big enough step in here. One thing I was pointing out, forgot to point out as well. Let me pull the tool out here, or no, you can see it. I got this much overhang, and I was showing you in previous footage. Here's the footage of the tool deflecting. Well, now the next step is going to be putting in a step. We're going to go take a look at the old gear. So we got to put a step in the gear blank that we're making right now, and it's going to be a press fit. So we want to get an accurate measurement. What we're going to do is take a measurement on the surface, and then the old gear gets bored out later and replaced. And in that process, we're also going to extend the hole or make the diameter of the hole slightly larger to get rid of any dirt, impurities, what have you, on the surface of the inner surface of the bore. Now, may not be necessary, but given the fact that we're boring this out already and trying to center it and everything else, might as well. And then that way on this blank that we're turning here on the lathe, we can make the matching size, and like I said, make it a nice press fit. So then we're going to be able to stick it in the vise or in a press somewhere and press it on in. Heating up cast iron isn't tricky. The only problem with it is it doesn't expand very much. Now we can try to heat up the old gear and make and see if the gear that we're trying to replace will drop out. The only thing I'm afraid of is that it might actually damage the old, the big gear that we're trying to save. So that's why we're going to bore it out, center it, bore it out, and then replace it with this one. So let's take a walk over to the mill and take a look at the gear that we have that we're trying to save here. So here's our old gear. As you can see, here's the broken tooth. And so now we need to get the depth of the actual gear itself for the length of the teeth, and then of course the bore. And we need to establish this bore here and find out what this is. So let me do that off camera. I'm handheld right now, as you can see by the wobbly footage. I do apologize. And then of course we're going to have to put grub screws back in, but I'm thinking we're going to go ahead and do it on this side next time around, as to avoid using the old holes. Okay, we know our old bore here is 30 millimeters. This diameter was 85. The depth is 86.5. The length of the teeth here is 38 millimeters. And then this bore back here is exactly 50 millimeters. So now that we got our dimensions, we can go ahead and get to work on the remaining steps of the gear blank. So as you can see, there's quite a bit of bounce here in the tool, and normally I would shorten this up, but because I have this step to put in here, I need to be able to reach in between the quill here. I got to run my carriage all the way back, and I'm almost to the tailstock here. And so now when I reset, you can't quite see that. There we go. It's coming into frame now. But now that I reset my tool, and I'm coming up, now I'm right up against the carriage, and I barely have enough clearance here for the tool to come in. So now that I know I need to take off 16 millimeters, there is a travel dial. Let me zoom in here. This is the travel dial on the carriage here. This is kind of handy. It's not the typical dial like you see on a lot of US lathes where it's time to engage the half nut. This is just strictly a travel dial. It's from Bergmars or something like that, Sweden, and it is fairly accurate. So I'm going to bump the tool up against the work here. Now I'm going to reset to 0, and now I don't need a dial indicator mounted on the track of the lathe here anywhere. Now I can just run this back and forth. I have my 0 set, and I've always, I can always come back to it. So now I'm just going to back it off just slightly into the carriage, or into the tailstock here, the carriage into the tailstock, I'm sorry. Now that I've got a few tenths here to work with, now I can go ahead and start shaving off that 16 millimeter on the length of the workpiece here. And I'm going to take that down to about the diameter of the washer here, and then I'm going to start in on the step. So let's go ahead and get started on that. Okay, I'm going to go in 2 millimeters.